Alright guys, welcome back to Bon Science. Today we will be going over Unit 2, Topic 3 in AP Chemistry called the Structure of Ionic Solids. And honestly, this one is really simple, and there's really only a couple of facts you need to know here. So first of all, an ionic crystal is just basically when you have an ionic compound but it's arranged in a crystal lattice format, or no, crystal lattice structure is probably the better terminology to use there. But essentially, with how the AP test this is they kind of give you diagrams, and they're like, okay, which of these is the ionic crystal? And so you just really need to know what an ionic crystal looks like. And so the way it looks, at least the way I've always seen it pop up on the AP as, is it's just a cation, which is represented by a positive atom, and then a anion, which is a negative, and then another cation, another anion, and it goes on like this, however much they decide to do, right? But you basically get this alternating structure of positive ion, negative ion, cation, anion, and honestly, that's as far as you need to go with it. If you, but like, there are a couple of things that need to be pointed out here. First of all, the crystals are technically 3D, right? Because this is like on paint, it's like it looks 2D, but like it is a crystal, so it's 3D. So like imagine like just a little salt particle that is obviously 3D. It's very small, but like atoms are tinier, obviously, and so there's like a bunch of atoms arranged in this like order, but it's like 3D. So you can just imagine this extending backwards, like into the paper, I guess, because it's 3D. And another thing is the reason it's alternating is because it's minimizing, or not minimizing, it's maximizing the attractive forces between the cations and anions, right? By putting the cations and anions together, you get the most force holding them together possible, and then it's also minimizing the repulsive forces. So as you can see, like there's no two cations directly touching each other, directly next to each other, because that minimizes the repulsion and it makes the crystal lattice structure stable. And that's really all you need to know. Now, one thing I have seen come up on the AP is they ask you like which of these represents, like they give particle diagrams and they're like, okay, which of the following represents a broken crystal? And this is super weird, but like imagine this crystal goes on, right? So I'll just draw it, right? Like super messy, but like here we'll say this is part of the crystal right here, and then there's like another part of the crystal that's like broken down here, not broken but like separated, right? It's not continuous with the rest of it, so plus minus minus plus plus minus. When they give you a picture like this, it just means that the crystal's broken, it's been fractured or something like that. It's like really random. I think I've only seen it come up like once, maybe twice, but just something to be aware of. But like the main thing you need to know is that when the AP is going to give you these like diagrams of like these alternating positive and negative charges, you're looking at an ionic crystal, which are usually 3D, but the paper makes it look 2D. But yeah, that's really all you need to know for this topic. So it's real simple, real short, and I'll see you in the next one.